Okay, hello. In this video, we are going to see this ring type CT. We will do a little bit of reverse engineering. That means I'll open up this because it's quite simple also to understand about ring CT. This is manufactured by Standard Gold Electrical Private Limited company, and the CT ratio is 100 by 5 ampere, right? So how do in this particular video I'll just be discussing, or I'll just talk about how do we get this ratio 50 by 5. All right, we'll open up this particular CT. We'll open up this to verify whether, without actually measuring, we will use the transformation formula for transformer, whether it's a potential transformer or current transformer. That formula should holds for both of them, should holds true, right? So I will, before I open this, because this is 100 by 5, then let me show you this formula. So the CT that we have just seen, the ring type CT, is CT ratio is 100 by 5, okay, in the secondary, right? So how do we get this formula, right? So you have to remember this one important formula for the transformation formula. We say v1 by v2 is equal to n1 by n2 is equal to I2 by I1. Okay, or in other words, we say that I1 and 1 is equal to I2 and 2. All right, or V1 and 2 is equal to V2 and 1. So these formula will be used. Okay, if we are to talk about potential transformer, then we'll have to talk more about this second equation. But if we talk about CT, we'll have to talk about this. All right, about this first one, or we have to just take this and this. That means if we talk about current transformer, the equation that we will be using is I1 by I2, which is our nothing but our CT ratio. CT ratio is equal to nothing but I1 current in the primary by current in the secondary. All right, which is nothing but N2 by N1. All right, which in our case we have got to be 100 by 5. All right, now this 100 by 5, that means because in the say in the number of turns in the primary, it's a CT ring, right? CT ring mean number of turns in the primary is 1 only. That means this n, let us reduce it to 1. That mean if I have to divide this by, to make it n1 is equal to 1, I'll divide this by 5, and I'll divide there also by 5. 5 5 1 1, and it becomes 20 by 1, right? So if we, in this case, that means the number of turns in the CT ring should be 20 number of turns should be there in the CT ring. Then I'll open up the CT ring. All right, that is I1 by I2, which is nothing but my CT ratio, is equal to N2 by N1 is equal to 20 by 5. All right, or 20 by 1. That means my, because in the primary, as I said, N1 in the primary is a single cable, is a single conductor only, it will be 1. So N2 will be equal to 20. That means if our ratio that we have seen there is 100 by 5 ampere, that means the number of turns in the secondary should be 20. Then I'll open up the CT. Okay, this is the CT. Okay, there should be 20 number of turns. Okay, without actually measuring, we will just open up this and see whether we have 20 number of turns or not, right? Before I open, just to show you also that this is P1. Okay, this is, I have already discussed in another video. If P1 enters inside, okay, P1 in primary, P1 enters, if current enters P1 and leaves P2, then our numbering in this is supposed to be S1, right? Red one is S1 and black one is S2. I mean that counterclockwise reaction, just like Newton's third law, will also be applicable. This is, if you put dot in P1 and then dot in S1 also. I mean, if current enters P1 like this, current is in this direction, then it will leave S1. It will leave this one. It will flow like this. It will leave S1, and internally it will be from S2 to S1, but outside the current will leave from S1. All right, this is the polarity that we have to understand. Okay, I'll open up this whether we have 20 number of turns or not. That is my intention in this video. There you see I have opened up this. Okay, then let me count how many number of turns. Okay, let me count how many number of turn. Let me take a pen. I'll count this. I'll take this as one turn, right? This is one turn. I'll start from here. Then 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. So it's very close, 19. It's very close to 20. We can say that this is 100 by 5 CT ratio, because we may not have exactly 20, but then the calculation is right, because we have to take into consideration the resistance of the coil also. All right, the volt ampere, we say the Borden, right? So this is how we have got the, because if you keep if we make it 20, then okay, 20 means if the Borden is there is no Borden, there is no resistance, so we have to make it short, I mean 19 to get 20 by 5. This is how we adjust, right? So this confirms that the ratio is correct, it's fine. All right, because if we take calculation as per the number of turns that we have here, 9, we got how much, 19, right? 19 into 5, 5 will get like that only, around 185 by 5, mean considering that if there is no Borden, but because of the Borden we have made one turn short, right? This is how we manufacture CT. So thank you.